right, let's do number 10. Number 10 is we're going to need to find the tangent line of this. The tangent line of this equation at this point. Once we have the rule for the tangent line, we're just going to test each one of these points individually and see if it lies on it or not. In other words, if it passes through it or not. So let's find the derivative of this first. It's quotient rule, right? The derivative of the numerator by chain rule is 2 times x minus 2 to the power of 1 times 1. And I don't have to write those ones. And then I times the numerator left alone minus times the denominator left alone minus the numerator left alone times the derivative of the denominator. And the derivative of the denominator is just 1. And that's all over the denominator squared. Okay, we could simplify it, but since we just want to put the value x equals 1 and minus 1 in there to find the slope, let's not bother simplifying it. Let's just put the number in right away and see what we get. So negative 1 minus 2 is negative 3. Negative 1 plus 4 is negative 3. Negative 1 minus 2 is negative 3. Times 1, that doesn't do anything, so I don't need to write that. Negative 1 plus 4 is positive 3 squared. So negative 18 minus positive 9. Minus 3 with brackets squared is positive 9, right? And 3 squared is 9. This is minus 27 over 9, which is negative 3. So the slope of our tangent line is negative 3. And this is the point that it goes through, x0, y0. So let's find the equation of the tangent line now. Once we know the point and the slope, it's easy to find the equation. We just use this little formula, right? The point-slope equation. X and y stay as letters, but y0 and x0 are filled in with these quantities. And m here is negative 3. Minus 1. If we simplify that, what do we get? Minus 3x. X minus 1 is really x plus 1. But then when I do negative 3 times plus 1, I get back to minus 3. These minus 3's cancel on each side, so we have y equals negative 3x. So that is our tangent line. And basically, we just want to see, the question is, which one of these points lies on that tangent line? So which one of these points lies on y equals negative 3x? The way we tell that is we just put the x value in, work it out, and if the y value that comes out matches this y value, then you know the point is actually on that line. So let's put 2 in there. Negative 3 times 2 is negative 6. That's no good. If I put 3 in there, negative 3 times 3 is negative 9. That doesn't match. If I put negative 3 in there, I get positive 9. Still no good. If I put 1 in there, I get negative 3. Still no good. But then finally, if I put negative 2 in there, negative 3 times negative 2 is positive 6. So our answer is E. All right, number 11 here. The maximum value attained by this function on that interval. Why don't we give it a name? Let's, I guess we could call it f of x or y. Let's call it y. So y equals that function there. To find maximum values, we need to, by the way, notice this function here is discontinuous at negative 4, right? Because that's where the denominator is 0. But notice negative 4, it's not even inside our interval, right? So that doesn't concern us. This function, being a rational function, is continuous on this interval. And so it does have a maximum value. It also has a minimum value. What is the way we find that again? Well, we're going to take the derivative. We're going to set it equal to 0 to get our critical numbers. And then we're going to find the y values of the critical numbers as well as the y values of these endpoints of the interval. And then in that list, the biggest number will be the maximum. It sounds complicated, but when we do it, you'll see it's not that bad. So let's do the derivative. It's going to be quotient rule, right? So 2 times x minus 2. By the chain rule, that is the derivative of the top. And then I multiply by the bottom left alone. And then I leave the top alone. And I multiply by the derivative of the bottom. All over the bottom squared. Now, here I kind of need to simplify this because I'm going to have to set this equal to 0 and solve for those solutions. And when it's a big mess like this, I kind of, it'll be too hard. So we do need to simplify this. Why don't we FOIL this out here? X times x is x squared. This is 4x. 4x minus 2x is just positive 2x. And then minus 4 times plus 4 is minus 8. And minus x minus 2 squared, that's going to be x squared minus 4x plus 4. Timesing by 1 doesn't do anything, so I'll leave that off. But I'm not going to multiply out the bottom. I'll leave that squared. I'll leave that factored like that because multiplying it out would actually be working against us. If it's already factored, we should leave it. The problem up here is this is not factored because we have this minus sign here. Factoring means that there is no, it's a product, right? And so we need to get rid of all these brackets and then reassemble it as a factored quantity if we can. Let's multiply this 2 across. So we get 2x squared plus 4x minus 16. And I'm going to take this minus across to everything. So it's going to be minus x squared plus 4x minus 4. And 2x squared minus x squared is just x squared. 4x and 4x is 8x. Minus 16 minus 4 is minus 20. X plus 4 squared. And this actually factors, I think, right? X minus, or doesn't. X plus 10 and x minus 2. So that's looking nice now. All right. Let's solve the derivative equal to 0 to find our critical numbers. Negative 4 is also a critical number because that's where the derivative is undefined. But like we said, negative 4 is not in that interval, so we don't have to consider it. What happens when the derivative is 0? Well, that means x plus 10 over x minus 2 times x minus 2 over x plus 4 squared is 0. Now, a nice little trick to remember is if a fraction is ever 0, that means the numerator must be 0, okay? So I'm just saying that if you ever have a fraction being equal to 0, then necessarily the top has to be 0, the numerator has to be 0. So my next step after this would just be to say that I would forget about the bottom, I don't even care what it is, and just say that equals 0. If you don't like that, you can maybe put this over 1 and do some cross multiplying. 1 times that is just that, and 0 times x plus 4 squared is 0. Now, from this, we can conclude that either x is negative 10 or x is 2. Now, these are our critical numbers, okay? Let's look back here. The interval that we're working on is minus 12 to minus 6. So notice that 10 is actually an element of that interval. Sorry, minus 10 is an element of that interval. But 2 is not inside there, right? So we only want to consider critical numbers which lie in the interval that we're considering. So what this means is that 2 is not important for us, okay? Negative 10 here is really our only critical number that's of any value to us for this particular question. Now all we'll do is make like a little table of values, okay? X, Y. Negative 12 and negative 6, since those are the endpoints of the interval, we have to include those. And then we have to include any critical numbers we found. And in this case, the only one that lied in that interval was negative 10. So all we're going to do now is find the y values here. The biggest number in this list will be the maximum value of what we're looking for here. Now, you know, for these y values, we're going to use the original function, right? Of course, we don't use the derivative. So it's x minus 2 squared over x minus 4. I'm just going to recopy that down here to make it easier to work out these three values. So the function we're putting these in is x minus 2 squared over x minus 4. What happens when I put each of these in? Let's see here. Negative 12 minus 2 is negative 14 squared over negative 12 minus 4 is negative 16. I'm going to need some more room here. Well, what does this give me? I'm going to use my calculator for that. 14 squared, negative 14 squared, divided by negative 16. So as an improper fraction, that's negative 49 over 4. When I put negative 6 in here, what happens? Negative 6 minus 2 is negative 8 squared over negative 6 minus 4 is negative 10. So it's 64 divided by negative 10, which is negative 6.4. And as a fraction, that's negative 32 over 5. Finally, if we put in negative 10 into our function, let's see what we get. Negative 10 minus 2 is negative 12 squared. Negative 10 minus 4 is negative 14. So we have 144 over negative 14, which is negative 72 over 7. I hope one of these is our answer. Those are all looking quite ugly. Oh, great. Oh, notice this is important here. We're, okay. You know what? The reason we're getting strange answers here is because this is a plus, isn't it? This was an x plus 4, so that'll be easy to fix. So all we have to do is just get rid of this stuff. Actually, all we have to do is get rid of the bottom numbers. So let's do that, and then we'll get back on track. And these will change, of course, as well. So let's see here. When we get negative 12 plus 4, that's negative 8, right? Negative 6 plus 4 is negative 2. And negative 10 plus 4 is negative 6. Let's recalculate these. 14 squared divided by negative 8. That gives us negative 49 over 2. I'm just going to write the decimal here as well to help us with the comparison to see which number is the biggest. This is 64 divided by negative 2, which is negative 32. And this is 144 divided by negative 6, which is negative 24. Which is, this question wanted the maximum, right? Which is the biggest of these numbers? Well, that would be this one, right? Negative 24. So I think that number is there, right? Negative 24, that's answer E. Good. What does 11 ask? Or what does 12 ask? Didn't we just dealt with this function, didn't we? That was x minus 2 squared over x plus 4. Okay, so this is good. We can use our work from before. We already found the critical numbers, didn't we? Remember the critical numbers? By the way, again, this function is undefined at negative 4. But fortunately, negative 4 is not in that interval. So this function is continuous on that interval. What was our critical numbers that we found? There was 2 of them, right? Remember we got rid of one of them? Our critical numbers were negative 10 and 2, right? So let's take it from there. The critical numbers. By the way, of course I'm using the previous question, because it's the same function. We're, I forgot already. -10 or 2, or and 2. Last time, we had to omit 2 because it didn't lie in the interval we were considering. This time, it's actually going to be the opposite. Notice that -10 this time does not lie in the interval we're considering, but 2 does lie in that interval. So that means we're going to keep 2, but we're going to forget about -10 when we do our little table of values here, okay? So when we do our XY table of values here, we're going to put the endpoints that we're working on, which are 0 and 5, as well as the single critical number here, which lies in the interval that we're working on. This should have been a 5. So this question will be quick. We just need to find these 3 y values. The biggest number there will be our maximum. Let's put in 0 into our function. 0 minus 2 is -2. -2 squared is 4. And the bottom is 0 plus 4, which is 4. So 4 over 4, which is 1. When I put 5 in there, 5 minus 2 is 3. 3 squared is 9. 5 plus 4 is 9, so we get 1 again. How about 2? When I put 2 in there, 2 minus 2 is 0. So I get 0 over 6, which is, sorry, is that right? Yeah, 0 over 6, which is just 0. The maximum there is going to be 1. It's actually attained both at 2 different places. It occurs at 0 and it occurs at 5. But regardless, the maximum value is 1. So that's the answer for 12.